wabarakatuh, and a very good morning. Please, Sadri wa yassirli amri wahlul 'uqdatam min lisani yafqahu qawli. Thank you very much for all the audience, and I would like to thank Malaysian Society for Automatic Control Engineers for inviting me to deliver this Monday Tech Talk. So my name is Ahmad Athif Mohd Faudzi from the Actuator and Automation Lab, Center for AI and Robotics, or we call as Cairo UTM. And today I will be delivering a presentation, a sharing entitled Emerging Technologies in Actuator and Automation Lab. Throughout this presentation, I will be giving an overview of the whole activity that we are doing in our lab. Roughly, we are applying our expertise in these three areas of Bioinspired, rehab robots, and field robotics. And in the blue box here, we have all the details of fundamental aspects that we are doing. And if people are asking what is the main work which is currently being conducted in our lab, so roughly we divided our main work in soft robots and in mobile robots, and also we have other activities that I will be sharing. So this is the structure of my presentation. I'll be starting with soft robots research, mobile robot research, as well as some of the commercialization activity, as well as some other work that we are collaborating with other partners. So soft robotic is one of the area which is currently emerging, and we are applying most of the application with this actuator, or we call as McKibben actuators. And we also develop our own actuator by a process like making cake process. So this is the McKibben actuator. When we supply air, it will be contracting, and we are going to have two values of contracting force as well as the displacement. So it will be smaller in size in horizontal after it is being pressurized. And there are many applications that we have developed. For example, the hexapod Giacometti system, the snake-like robot, and we also developed a robot neck like this one. And we have also some of the bio-inspired work like this human robotic hand, lower limb musculoskeletal robot that we work together with Institute of Technology, and also the soft amphibious robot. Some of this work I will be explaining shortly. So I would like to start with a PhD work by one of my students that we co-supervised by Dr. Sultan, entitled the Bidirectional Bending Pneumatic Bellows. So this is an actuator which is not using the McKibben muscles, but we developed from scratch. So the background of the work, we would like to have a robot that can do some inspection to help the doctors in doing the operation. So there are many kinds of open surgery. We also have this minimally invasive surgery that we can try to use some of the advancements of robotic inside. So we proposed a soft-based actuator that could do inspection inside the body. And this is some of the materials that we are using in comparing with Shin-Etsu silicon as well as the Dow Corning silicon. And we simulate the performance of the robot in a software finite element analysis to identify the performance when we pressurize the system. And we fabricate the system as what I've mentioned. It's like a cake process. You have the mold, you put in your silicon, and then you have to eliminate or vacuum the the bubbles, and then you're going to have the structure after you have connected using some silicon. So there are several experimental setup that we are using, having a compressor control it together with the valve, and we use some bending motion analysis to do the performance of the structure. So this is the comparison that we do together with the finite element analysis to validate the performance. And The second structure that was developed by Dr. Tariq is on dual channel square bellows. So if you look at the previous one, it was one direction, but for this one, it's a bidirectional system where when we pressurize the structure in left side, so it will be bent in the opposite side, and for example, in this side, we pressurize in the left side, it will be bent in the right side. If we pressurize in the right side, it will bend in the left side. So same for the samples that we do in simulation. Then we fabricate it, and actually the second version of dual chamber or dual channel square bellows is using a method of sacrificing the mold itself, because the structure is very small. The structure is around 2 millimeter in width. So, but then we apply the same process using different kind of silicon. So this is a PDMS based silicon. So the same method that we use to analyze, as I have just mentioned earlier. The second project that we would like to share is applying the soft McKibben actuator. And currently, one of my PhD students, Mr. Hazwan, is currently doing on this topic of investigating the finger pinching using the McKibben actuator with machine learning adoption. So this is actually a work that we work together with TIT as well as Toshiba back in 2017. So this is part of the motivation of the work where most of the grasping and manipulations are using different kind of actuators. Currently, we are exploring the usage of using soft material. And what we do differently in this study is to look at the hand anatomy closely. So by looking on the muscles, the ligaments, the tendons, and how we can replicate. So we can see how complex Allah subhanahu wa ta'ala, structurize our finger, and how it gives its functions, okay, how it gives its function. So now we roboticists try to learn from what the created structure that our God have been given it to us. So Alhamdulillah, so this is part of the study that we are doing, and we try to mimic the structure of the hand. And we see that there are not many researchers looking for the actual hand type of work, because many people are simplifying the structure for a certain purpose, but our purpose is to more on studying the fundamentals of the hand. And we see that Yoki Matsuoka is one of the um, main reference that we look for in our work. So we try to mimic in terms of the ligaments, looking at how the rotational joints, and we identify when we have different assemble of the ligament, it will be giving some error in terms of the motion. So this one is much more smoother as you can compare with the earlier one. So currently we are comparing also some of our work with the cadaver motion, and we are doing it in replacing the function of muscles. This is actual muscle, and this is our McKibben muscle. And my students now, Hazwan is looking for the conceptual framework to investigate on the model, as well as applying machine learning as part of the pinching function for the index finger and the thumb motion. Okay, so the third projects that I would like to share, also a PhD work by two of my fellow researcher, Firdaus and also Mr. Tahir. Firdaus is developing a soft extendable manipulator, also using McKibben, but Tahir is using the tendon base for its manipulator. And the application is roughly similar for inspection purpose, but then with different kind of specification. So there are a lot of robots that in doing in continuum manipulation. For example, this Giacometti arm by Suzumori Group. We have also NASA long arm, Super Dragon, the growing robot from Stanford, if I'm not mistaken. And most of these robots are being used in inspection purpose. And we can see that there are some advances and also the disadvantages of using different kind of system. Although the current robotic system is having its accuracy, but when accident happens, So it's like the Murphy's law lah. Okay. This is one of the problem statement of using pneumatic artificial muscle as part of the alternative actuator, and we can see that although pneumatic muscles have this disadvantages of less accuracy and not so fast, but we can see the softness of the structure as well as the compliance can be used in this area of inspection. So that's why both of our researchers is looking for this structure. So this is an example of how Firdaus is looking on using balloon type system and apply McKibben actuator to manipulate the motion. So if you can see inside this video, so we have like a balloon structure here, and we can control the movement of the actuator by manipulating the McKibben muscles. And we have to control also the pressure of the balloon. If not, then it will be exploding. Okay, so we have the applied pressure and the breaking point that we have to identify. And currently, we are looking for more than 1 degrees of freedom. So this is how Firdaus is working, and also to see the manipulation can be used in search and rescue. And something similar with what Firdaus is doing, but then using different concept. So our brother Tahir is working for irrigation control using soft manipulator, an elongation type of soft manipulator, applying continuum structure as well. So the idea is on how to be used in canal system in the future, and currently using this long arm, roughly around more than 50 meter of arm, sorry, 50 centimeter. So we can see how we do the comparison of the model as well as the current structure that they have, that Tahir have developed. Number 4, a project by our master student, finishing inshallah, CZing on soft robotic glove using McKibben actuator for hand rehabilitation. Now, one of the intern students is helping her in developing the structure. So initially, one of our alumni, Dr. Ili Naja Aimi, finished her study on doing something similar of using not McKibben, but she developed her own bending actuator. Um, and this is what Ili was doing last time. She controlled the pressure inside, and we can have different angle at different input pressure. So this is an example of her work. When we apply pressure, then the structure will be bending. Something similar like the project that proposed by Tariq in the first project that I've showed, but then this structure is bigger and the force is higher. And this is what Ili did last time. We have master and slave, and this project was also completed by one of the undergraduate student, Mr. Zulhilmi. Okay, so what Ziying is proposing is something different. One of the structure is in terms of the glove type, that she will be using silicone rubber with a simple attachment. Initially, she did this glove type, and using the McKibben muscle, we can control the finger motion for flexion and extension. And we can see the full flexion and full extension by using the McKibben muscle. So her novelty of work is in terms of how to manage the muscles, which is contracting at 20% of the original length. So she proposed a pulley method. By using pulley, she's studying on the force as well as the contraction ratio, the displacement of the muscle itself. So the application is on rehabilitation, but then her novelty part is on the designing of the double groove pulley system. Okay, so we are at number 5 project. Another PhD is working in the material area, one area that we are exploring and working together with our collaborator, Dr. Ilango from UCSI, as well as some of our internal expert, Dr. Saiful in biomedic, bio, biomedical department. So her study is on the CQ reinforced medical grade silicon for human stem cells. Okay, so we see that one of the issue in cartilage is in terms of looking at the value. I mean, if there are some accidents happen, so there are some issues of CQ that need to be regenerated. So especially in the cartilage area. So one of the study now is to use soft material. The material that we are looking for is the medical grade silicon, and we want to reinforce the structure with natural fiber extracted from the CQ leaf. So mostly CQ leaves are being used in India, Malaysia for traditional kind of treating bones. So we want to study on using CQ. So we have two phases: the synthesis of the structure. We want to look at the mixing and identify the homogeneous of the structure. Then we want to conduct the mechanical test, and later on the in vitro test that we are going to do together, and lastly to compare and identify the performance of the structure towards the bone application. Okay, and another work which is still in the soft related area that we are doing, but the novelty part is more in control. Okay, so this is what our brother Akmal is doing to develop a double acting cylinder, and it is actuated by a McKibben muscle. So he is developing a new type of actuator currently using this McKibben structure. So if you see here, the conventional cylinder normally use two rooms of chamber. So this is a double acting one. Once we supply the pressure in this area, we can have the motion of stroke in the right side, and then when we pressurize the second chamber in the right area, it will be contracting back. So using the same concept, but then the application is applying McKibben actuator. So you can see some of the initial work, and we used the linear sensor here to identify the movement. And what Akmal is doing is to do controlling of the position of the actuator. So we will try to control in taking care of the limitation of the structure of McKibben. So this is what Akmal is trying to apply now, and currently he is using PI control, and we are looking forward to apply some of the predictive control as well in this structure for him to validate. And project number 7, a project which is soon to be completed, a biomimicry robotic eye using tin McKibben. So if you see throughout the presentation, we have eye, we have finger, we have hand. Okay, so these are part of Bioinspired project that we look through in our lab. So what Winsoon is doing, and this work is also collaborated together with some of our researchers, Cairo researchers. Puan Neni is helping in this structure of eyeball and cradle, and also Dr. Mustafa also one of the initiator for this project. What we do in this project is to identify the muscles of eye and to study on the agonist and antagonist movement of eye. So what currently Winsoon is doing is to use a camera attached at the eye structure, and then from here, once we have some object, so it will be trying to detect the movement, and the eye will be moving. So this is one of the calibration process that he did. Unfortunately, sorry, the media was not installed properly. So what we did here is to see the accuracy of the structure control in open loop for the movement for up, down, left, and right. Okay, so this is the application which Winsoon is doing in tracking and surveying of the motor using the McKibben muscle. Okay, so now I would like to go for the second area. So we started with the soft base, soft structure. We can see different kind of robots available. And now we want to go for these mobile robots. There are few which I would like to cover later on in terms of, for example, one work by one of our researchers, Zangna. Maybe I mistakenly put under mobile robots, so I will show this later. So in mobile robots, we are currently investigating on UVC. People are mentioning, the literatures are mentioning that UVC could be used for this infection purpose. Um, So we received one internal grant from TNCPI UTM, and now we are conducting a work to deploy the structure of autonomous mobile robot, and we also tested in quantitative study together with Dr. Saliha Group under Cancer and Infectious Disease Research Group UTM. So this is a work that we are continuously running. What we did was mapping the area that we want to disinfect, and after mapping, we set the set point, and the robot will be doing its motion. So the challenge now is on the power management, the stability of the structure, as well as the um, impact of the UVC towards the samples of bacteria, virus, or maybe spores or fungi that you would like to do. So in qualitatively. Telepresence robot is also an area that is not soft. So I put together in this area of hard, or we put under mobile robot. So we want to have a robot that can do telepresence. The structure will be mobile, but then the upper part will be having its arm. So this is a project that we collaborated with Ericsson in having an arm that can be mimicking our motion. So we use virtual reality image here. Our researcher Wang is looking at what the camera here is looking. So this is the vision. And in 2019, Apple, during Tun as the previous prime minister, so we showcased this during this 5G showcase in Putrajaya. And we also developed a smaller scale of robot that can have both arms functioning. So if you have watched this Real Steel movie, so we try to realize the structure for good use, not for boxing. This, like maybe in the future, if we have some other work that can be monitored or manipulated through a distance, so we can use this kind of technology. So this is under the telepresence work. And interestingly, we presented to HSA as one of our proposal for COVID last time, but now we are trying to apply some of other grant. So we would like to use this system for troca. Troca is like inspection after to do biopsy, okay, to handle any patient which is having cases, unknown cases. So how the robot can be taking samples of the patient with a distance. Okay, so this is Dr. Azno, the head of forensic department under HSA. So we have our tank cleaner as part of the mobile structure that we are currently pushing it forward for commercialization activity. And initially the work is towards water utility. Yeah, we know that Selangor is having difficulties in the water issue now. Hopefully it will be settled. What we do is to help in maintaining the tanks, okay? And we learned that manual way will be having more non-revenue water, and diverse you have tendencies of accidents, and also the cost is quite high. So we are giving alternatives. So maybe it can be uh, compensating some of the current available work by using robots to do inspection as well as to do cleaning. So this is an example of cleaning process that we've conducted. So you can see the water quality in this tank is very, very bad. So we do cleaning and demo for some of our partner. And this is a ground a ground type, a ground tank, okay? A ground tank, so not so high. We have an elevated tank. Here is still ground, where robots can be used easily. So we see here the potential of this work is high. Currently, we are exploring a collaboration work with FQ Fleet, one of the company uh, in prawn business, shrimp business, in aquaculture. They have to clean their tanks every day, okay, and they have to use a lot of manpower. So having a robot to clean is one of the alternative as well. So we are looking forward for this application, and this is a work that we are collaborating with different partners. UTHM, Dr. Ubay is having its expertise in SLAM LiDAR, so we are collaborating with him. And Dr. Athif from UMP is in the area of AI, would like to collaborate in terms of optimizing the movement of the robot. We applied for my lab and now waiting for the approval. So project number 11 on navigation planning in the ducting. Sorry, this is a work that is conducted by Mr. Ridwan. He will be presenting his first proposal 14th of this month. And I believe that his work now is more than the is good enough for his proposal defense. So this is the work that he did for the first generation of the robot. Now he's in the second generation of the robot, doing the simulated model and trying to look on the PRM, probabilistic roadmap algorithm in conducting inspection and cleaning inside the robot. Inside the duct. So this is some of the initial work that he presented using SLAM and the percentage of errors available. And some of my researchers, including Ridwan, is working forward for the commercialized project that we are doing, inspection and cleaning. We call the robot as Kirero. Some Japanese background audience may understood this meaning, and we are looking forward in doing inspection. Most of the maintenance currently still manual, but then we want to know the condition before and after, and that is where our robot will come. So this is our developed robot, and we control this robot using phones and easy to be set up, just plug and play. So we can comply the structure to any phones, any application, either Android or iOS, so no issue in terms of applying the structure. So hopefully this will be a go for commercialization, inshallah. So in others, okay, now I'm at the third part of my presentation, where I would like to share some of other work which is not related to soft actuator and also not in the area of mobile or underwater. So we are using some of our experience in pneumatic cylinder to develop our ventilator. This is related to COVID-19 issue. And this is not our area, and we are learning and exploring and working together with our collaborators from Hospital ATM, Angkatan Tentera Malaysia, as well as Hospital UITM Sungai Buloh. And we developed our first prototype using this ventilate model, and we control the structure using cylinder. And this pneumatic cylinder is actually my previous study when I was doing my PhD. And most of my work now is not related to cylinder, but this is like a comeback research related to cylinder. And one of my student, Dr. Will, is currently looking for cylinder kind of work and controls of the structure. Example of the movement. So the cylinder will be moving forward and backward, extending and contraction, like just similar like what Akmal is doing, but then this is the normal, double acting cylinder, and the structure can be controlled for modifying the values of pressure as well as the volume. Okay, and we can see this. So this is a work collaborated with different industry partner, because during very short time in April, where Malaysia is looking for alternative in the case of emergency, we don't want to be in the similar state as Italy if the spike is exponential. So KKM was one of the under the initiative from UTM and KKM, so we come together and develop this prototype. Currently, we are working with Medivest, and we are developing different kind of structure. We receive some of the available in ventilator, the model PB, and we are now doing some reverse engineering to enhance the current model of PB, and also to apply later in the area. Okay, so another work that we are collaborating together with internally as well as internally we have Dr. Shafiz and Dr. Hazina in looking the AI application for counting cars, and these are part of the study we do for management of CIQ. Okay, between Singapore and Johor Bahru, how to reduce the loads and try to manage the flow. So the work here is very important in applying AI technology, and one of my researcher, Mr. Sheikh, is working on this study together with Faiz and few others. Pinlun is also one of my FPs looking for Tableau-based data visualization. So based on the data that we have here, and we do some prediction of the traffic flow. So at every 5 minutes, how is the traffic will be? And these are some of the analysis that was conducted. And these are examples of pictures that we've taken and how we use AI for the accuracy of the validation in terms of the movement of cars and the counting of the numbers. In our future direction, so I'm at the end of the presentation. Um, we are looking forward in trying to see how our robots can be used in helping the biodiversity part. Okay, for example, the turtles, the sharks, the coral reefs. So I'm working together with one of the groups under ASM in applying some of the advances of robotic, and I would like to open as well for others who are in this area. Maybe we can work together and try to enhance. What we have now in Cairo, a work by Dr. Zol using AI and drone technology in counting cows. Okay, so this is a work that was conducted earlier. So we can see here from this video, numbers of cow counted is 24 cows within seconds. I think our bare eyes cannot do the similar counting. So from here we can try to use AI. I'm sorry. We can use AI and also work for underwater counting turtles, managing the reefs, and also looking at the sharks available. So we can also help in terms of collecting waste, preserving and monitoring plants. And we are also working with MBIP now for one of the projects in water quality, and also from together with Ericsson in the preserving the using mangroves in some of the area in Selangor. Okay, some of the challenges here are written here. What are the challenge is the inadequate of manpower. So I would like to call for any of our viewers who are in the area. Maybe we can try to collaborate and looking for any solution that we can come out for biodiversity direction. Okay, I think I'm at the end of the present at the end of the presentation. So I would like to highlight some of our collaborators in terms of the networking that we have in Printis. We have from Asasi under MACE themselves itself. We are also working together with Academy Science, YSN. So these are part of the members that we are collaborating in professional body. We also have local universities in some of our projects, industrial partner that we are working in some of the work, partly in commercialization, partly in CSR, also in government agency like KKM, HSA, MBIP, and POB. And thanks to our international universities, some of the work that we have, we send our students and we receive some of them partly to build the environment better. And in YouTube, we aim for star consortium ideas, and partly this is what we are currently conducting in our lab. These are some of our activities, in-lab activities, together with the interns, the industries coming for discussion. We went to HSA. We have our dinner together, and some of the collaboration work that we do with Jabatan Pendidikan Negeri for helping the young generations as well as collaboration with industries. So thank you very much to all of you. A saying by Colin Powell, a dream doesn't become reality through magic. It takes sweat, determination, and hard work. And this is not a silo-based project. So this is a collaboration work between different, the stuff that I've showed earlier. And also internally, I would like to thank all of the A2 Lab members for your kind contribution. And one of the verse in Al-Imran 159, فَإِذَا عَزَمْتَ فَتَوَكَّلْ عَلَى اللَّهِ. So we have to put our effort, put our goals, and put our effort, and we leave it the rest to our God, Allah subhanahu wa ta'ala, for us to be successful in the dunya and the day after. So thank you very much. Gotecho arigatou gozaimasu. Thank you for your kind attention. And although this is a live presentation, but we would like to stop here. And if you have any question, you can put down in the comment section, and we will try to reply your questions soon. And you can also email me for any assistance that we can provide. So thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.